Hey y'all, in this video we're going to go over question 1 from the Conservation of Energy worksheet. This question reads, a 50 kilogram roller coaster car is launched 5 meters off the ground at 25 meters per second. How fast will it be moving when it reaches the top of a loop, which is 12 meters above the ground? So let's start off by labeling what we are given. So we have 50 kilograms, which is the mass, and it's launched 5 meters off the ground. So that is going to be its initial height that it starts from, and it's going 25 meters per second. So that is our initial velocity. And we know that because the meters per second is a unit for velocity. Then it asks us how fast will it be going. So if we're talking about how fast, we're talking about velocity. In this case, we want to know how fast it's going after it does something. So it'd be final velocity. And in this case, it's after it reaches the top of a loop, which is 12 meters above the ground. So that would be its final height. All right. So based on the type of worksheet we're doing and the information given, we know we're going to use the conservation of energy formula, which is mghi plus 1/2 vi squared equals mghf plus 1/2 mvf squared. All right. So it's a really long formula. Well, if I can find my pointer. But this is technically the potential energy formula. This is kinetic energy formula, potential energy, kinetic energy. So it's your initial potential and kinetic equals your final potential and kinetic. So it's really long, but it's really just those two formulas. All right, so let's go back and solve this. So you're going to plug in everything you know. So you're going to have 50, G is always going to be 9.8, and your initial height was 5 plus 1/2 times 50 times your initial velocity was 25, and that is squared, equals your mass again is 50 times 9.8 times your final height is 12 plus 1/2 times 50 again times your final velocity, which is what we want to solve for. Right, so the whole lot, but we're about to shrink this down by simplifying everything. So I'm going to simplify this into each part. So this first section of 50 times 9.8 times 5, you're going to multiply that, and you are going to get 2450 when you do that. Then the second part, when you simplify that in the calculator, you should get 15,625. And then this third section is going to simplify into 5,880. And then the last part, we're going to simplify this down to 25 VF squared, right? So then we can go ahead and simplify this a little bit more. And that on the left side is going to be 18,075 equals 5,880 plus 25 VF squared. All right. Now from here is where I see a lot of mistakes. People tend to want to add this part together, the 5,880 and the 25. Do not do that. All right. That is incorrect math. All right. So instead you're going to subtract that 5,880 to the other side. So it's going to give you 12,195. So we subtracted that over to give us 25 VF squared. Then we want to divide both sides by 25. That's the correct way to do this. And that's going to give us 487.8 equals VF squared. And we don't want to stop there because we don't want BF squared. We want VF. So we're going to square root that. And when you do that, it's going to equal 22.1 meters per second. All right. So it's a really long formula. It's a lot of steps. I highly encourage you to write this down, even though it's a lot, because it's easy to make mistakes if you're just typing it straight in the calculator. But you'll only see a couple of these on a test or a quiz. All right. Let me know if you have any questions.